right, everyone. I am here with my friend Robert Osazuwa Ness, and we're going to spend a few minutes chatting about the interview and how it relates to his causal modeling and machine learning course. Robert, welcome back.
Hey, Sam, thanks for having me again.
Hey, why don't we just get started by having you just kind of riff on the interview and how it ties into the themes that you've covered in the course. We've been doing the kind of joint AltDeep.ai, that's your education company and Twimmel collaboration for about a year and a half now. Maybe four or so cohorts so far?
Yeah, it's been a good collaboration, you and I. And I enjoyed the interview with Sean. Is somebody we go a ways back. I think I first met him when I was running a meetup on probabilistic programming back in the Bay Area. And he came and talked about Prophet, which was the forecasting software he built on top of probabilistic programming language called Stan.
Nice. And so did any particular themes jump out at you from the interview? I think you prepared some clips that you wanted to
Yeah, I
talk through.
took some snippets here. It's funny. I've had these, it's actually tangential to some conversations I've had recently. He talks about, so one of the approaches that we focus on in our course is a generative modeling approach to causal modeling. And some of those themes came up here. And so, for example, he talks about heterogeneous treatment effects.
Heterogeneous treatment effect says, hey, maybe that pill works better for some people than for others. And we like the machine learning model to give us some idea for whom it will have stronger treatment effects. And if you think about this as a label data problem, it doesn't work, because I would like to take a vector for you and predict an effect. And I'll never observe you getting the treatment and not getting the treatment. So I can't actually estimate a per observation treatment effects.
Yeah, so one interesting thing, if you take a generative modeling approach to causal modeling. So what you're doing is you're modeling the distribution of the causal query. So say you want to know what the causal effect is of this treatment on that outcome. You're looking at the distribution of that outcome under the intervention, under the treatment. And so from a generative modeling approach, since you're just directly modeling the distribution, heterogeneity is built in, right? It's a distribution. And so its spread quantifies uncertainty. It quantifies the diversity of a population. And so if you want to then so what that allows you to do is take modern probabilistic modeling tools, many of which are using cutting edge deep learning, auto differentiation architectures to do inference, and just say like, okay, well, I have this distribution. What's the probability distribution of this treatment on this outcome? What's the probability distribution of this treatment on this outcome if this person were over 6'5" and likes to ride bicycles, right? And so that's all. Just we have modern tools in probabilistic modeling that we can just apply directly to those problems, and so that's the approach that we take in the workshop, because many people actually already have some skills in using some of those tools, for example, PyTorch. But there's also one of the things that popped out to me in this interview was kind of talking about the joy of modeling. And that's something that really resonates with me. You guys had a conversation about flow state.
I talk to people about it all the time. I think getting into a flow state is really something that you should try to make your work facilitate. And so I really want to get back to doing stuff where I lose track of time and are able to make big progress on projects with a little bit of time and space.
I could think kind of back in my career as a statistician, data scientist, machine learning engineer, where I learned some technical skill and it dramatically improved just my experience at work. Say, for example, I learned a little bit of functional programming, how to apply it to exploratory data analysis. I learned probabilistic programming and how you can compose smaller programs into bigger programs using some ideas from category theory to model complex systems. And it was great. You can solve new problems. And, more importantly, I think for me personally, more importantly, was that aside from the productivity gains and the ability to do new things, it was just funner, right? Like I was able to get into that flow state. There's other sources of joy, right? Ecstatic bliss, Fiero. I don't know. I don't care about those. Like I really care about just getting into a deep work type of mindset and being able to do cool things with my data, with cool tech. And
is the idea that causal modeling provided some of that for you?
the approach that we're working on in this workshop does, right? So a lot of causal modeling, if you go to the textbooks, it's just like, let's construct an estimator for this identifiable estimand, and there's a whole bunch of theory and math, and it doesn't really, it's almost as though you have to learn a new degree just to be able to apply these methods, when if you can take some of these concepts from generative modeling, from probabilistic programming, from in some cases functional programming, and connect it to your intuition and understand how bits of a causal model can compose together like programs, it actually makes it frankly much funner than other ways of going about it. It also makes it easier to learn, and it makes it easier to apply. And so that was one of the things I got to thinking about when I listened to this interview with Sean.
Nice. Yeah, I've often found it interesting when folks ask you, what are the prerequisites for the course? And you reply, well, some basic probability, but it's not like you need to have, some deep theoretical grounding in causal modeling or causality or statistics or anything like that.
Yeah, and obviously those things would help you if you wanted to apply it to a specific applied problem where, say you're working with some variable that has a lot of nuance, and in terms of statistically modeling it, or you need to understand a little bit about, say, I don't know, measure theory. That's possible with a specific class of problems, but it's completely separate from the problem of applying a causal model to the problem and reasoning about it causally.
Mm-hmm. Did you have any other clips that you wanted to share?
I don't know. Here's this bit. Guys were talking about leaky abstractions. I think it relates to what we were just discussing in terms of reasoning about a causal model as a program that you can build on iteratively, and apply some unit testing to have an explainable model and kind of build a component of that model where one thing is working, and then you can move on to another part of your causal model so that you can grow it into something that is building value for you and your organization over time.
And so I'm wondering, like, the interface, I guess the thing that I'm thinking of is like leaky abstractions. Like, do you, how does that manifest in trying to use causal models in a real world scenario like this?
Yeah, I love that question. I've been telling my team we've been working on this for about 2 years now, is that we're not building a model, we're building a system for building models that's going to evolve over time to help us make agile adjustments to the way the business runs, or as we have new information.
That resonates with me because two things. Number one, a lot of tools in machine learning and statistics, they kind of encourage you to get really good at learning the tool. They black box most of the workflow, and you just kind of learn some kind of art of hyperparameter optimization. And with these types of causal models, you need domain knowledge, and so you need to be thinking in very detailed ways about the data generating process. And so if you make clear composable abstractions of that process and focus on some small element of it to start with, and then build it up over time. And also the inference algorithm. If you can separate the model from the inference algorithm, you can perhaps use some cutting edge deep learning techniques for probabilistic modeling, say stochastic variational inference. And you learn how to make programmable inference and build that up over time. Not only do you have something that's more robust because you can make sure that each component is working in isolation before you bring them together, but also something that builds IP over time for your company. And this is a lot different from how causal inference is usually taught, because it's usually taught as though the problem that you're presented with at the beginning is the only problem that you're ever going to face. And so if there's a new problem, you have to start from scratch and build a new model. And in a production setting, that's not a good approach.
Well, your target participant for the course is someone who's thinking about these problems from an engineering perspective, as opposed to a traditional statistical perspective, whether that's in the kind of sciences or social sciences or what have you. which is a lot of where causality's been where folks are thinking about causal models and causality. Is that right?
Yes. So, you guys had this blurb.
And so we have to incorporate the effects of our previous decisions into the forecast. So there's really like a rich space of modeling problems just within forecasting. And it's really never going to be as simple as just take this line and extrapolate it into the future. And we have to think about a system rather than just like just a particular model.
Do you think about incorporating in the potential decisions that you could make into your forecasts? How do you close that loop? Do you end up using simulation techniques or other types of techniques to do that?
Yeah, it's at the end, our forecasting system is designed around causal models.
Right. And so that, at least currently, is the killer app for causal modeling in production. In most settings, if you're building some kind of predictive algorithm, it's going to generate a prediction that you are then going to use to make a decision.
Mm-hmm.
But often, in fact, more than often, the outcome of that decision impacts the data that your algorithm is going to use to make future decisions. That feedback loop can cause a significant amount of bias to the algorithm. And so, yes, that is the main engineering use case. That said, we have lots of researchers in applied fields who are trying to get a global perspective on causal modeling. Many people from public health and many people from economics, for example, who maybe have learned a few specific causal modeling or causal inference techniques that are popular in their domain, but don't really have a global understanding for the theory.
Got it. Let's maybe switch gears and talk a little bit about the course itself. What's the structure for the course?
It is a cohort-based course. We have online lectures and videos. We have programming assignments, and we have a weekly retrospective cohort meeting where we go online and talk about that week's lectures, answer questions, maybe workshop some people's individual problems. And then alongside, we have some reading groups with previous students who are interested in talking about adjacent topics. And then we have a project-based element to the course, such that if you're trying to build a project, where you can apply these ideas, we'll provide support with that, and you can team up with other members of the course to come up with a good project outcome.
Can you mention a couple of projects that students have taken on?
Recently, one student used a deep learning technique called normalizing flows to implement a counterfactual reasoning algorithm on images. Some other students used, these students were fans of soccer, football, and they built a causal model that would predict the outcome of a trade. Other students, prior to COVID, this was a really cool project. They downloaded a bunch of Airbnb data, downloaded a bunch of real estate data from Redfin, and then composed them into a model that would predict how much, basically, if you wanted to buy a house with the goal of maximizing revenue from Airbnb, it showed you, basically created a search engine for, Airbnb optimal properties. Then post-COVID, some people did some really interesting things with epidemiological models and adjusting them so that they were using causal reasoning.
Nice. And all of that might sound intimidating to some folks who would be perfect fits for this course. In the past, you've made a point to make sure to let people know that they can kind of adjust you get out of it what you put into it, and you can take it at different levels. Can you elaborate on that a little bit?
Yeah. So if people are busy, a lot of people are full-time employed who are taking the course. And so we set it up so that you can move at your own pace. If you miss a week because of work, you can hop onto the cohort and get fairly caught up in the review section of the cohort. Obviously, if you were going to go deeper into the videos and the homeworks, you'd get more out of it. But it's set up so that you're never in a position where if life happens, you kind of get left behind the rest of the course, and you won't have the time to continue. You'll always be able to catch up and get as much out of the course as you can.
Awesome. Awesome. Well, there's a ton more that we can go into. One of the things that past students have raved about is the access they get to Robert and the one-on-one guidance that he makes himself available to deliver. But really, the next step is to check out some more information about the course. And you can do that at twimlai.com/causal. And thanks for tuning in. And thank you, Robert, for joining us.